being an IA for EECS 370, and I'm going to be talking about the caller and callee save. So caller and callee save is a pretty important topic in 370, and it's useful because it deals with the fundamental aspect of I guess programming and assembly, which is storing a variable such that once you restore it, its value doesn't get changed by other functions, and it so the integrity of the variable remains the same. So we'll start by saying what a caller and a callee save is. So caller save is basically a save that you do before save and restore, I guess, that you do before and after every function call that a function does. So you save the registers or variables that you want to save before the function call, and you restore them after the function call. Now, one of the main aspects behind which functions to save and restore is the function that you save, the variables that you save or restore must be live across the function call. Now, what does that mean? So a live variable means that its value is being used for other purposes, like assigning a value, another variable the same value, or doing different kinds of stuff. So the function needs to be live for a caller save. Now, callee save is what a function being called is doing. So what it does is it saves the variables and registers that it uses for its own purposes. For its own purposes, it stores them before the function starts, and it restores them after the function ends. The main body of the function, I mean. So the main reason for this is for the variables and the registers of the function that is being called to not be changed by the function that is calling them or any other function in the program. So now we go on with the conventions, and I think it's important to note that a caller and a callee save are protocols. They're not something that are set on stone. You can change them, but the basic criteria of changing if a variable should be saved using a caller or callee save is how many loads or stores in total are you doing in a program, and that makes it more efficient. Okay, so what we usually do in a program is we usually take a variable or a register and we assign it with what type of save that we're trying to do with the variable so that we get the least amount of loads or stores. So let's say there's a variable A. If you do a caller save, then it's like two loads and two stores across the function, and if you do a callee save, then it's one load and one store. Then you would be tended to favor the callee save because there's less amounts of loads and stores. So let us move on to the actual function example itself to make it more apparent what I mean when I say caller and callee and all of the different live function call that I've been talking about. Okay, let's look at this function link right here, and let's do a caller save based approach to all of these and a callee saved based approach. So let's think about the caller save. So we're calling a function foo right here, so we need to do a caller save, and we know that we are using every variable after the function is called, so every single variable is live across the function call. So what we do, I guess, is you load and store every single function. You store it before the function is called, and you restore it after the function has ended. So you end up with four loads and four stores. So for the other function right here, foo, what you do is you're calling a function called bar right here, and you use enf. So you do two loads and two stores for enf. For bar right here, we're calling final. We're using GHNI, so we only do three loads and three stores. For final right here, it's a leaf node, so it doesn't call anything, so we don't do any call or save for any of these functions. For a callee save, main is not being called by anything, so you don't do any callee or call or save. For foo right here, we know we are being called by main, so we need to store both enf and restore it at the end of the function. For bar right here, we know we are being called, so we do four loads and four stores for bar. For final, we know we are being called by bar, so we do two loads and two stores at final. And so what we have got for a caller save is we've got 9 total loads and 9 total stores. For a callee save, we have got 8 total loads and 8 total stores. So you can see right here that if you assign a function, variables inside of a function with a specific saving protocol, then you can probably decrease the amount of loads and stores that you need to do, and you'll get the same result as doing it with a completely caller or completely callee save. So that is it with the caller and callee save. We know these are very important topics. These are extremely confusing as well, in the sense like if you have if you have a for loop, then how many loads and stores you do. Those are all a lot of aspects arise from these basic concepts, but the things that I've been talking about for the past 5 or 6 minutes are the basic concept of a caller and callee save. Thank you very much.